Welcome back to the deep dive. This is where we take a whole stack of information, really sift through it, and pull out the most important, well, nuggets of knowledge and maybe some surprising insights just for you.
Yeah.
Today, we're doing something I think is genuinely fascinating. We're kind of pulling back the curtain on how a really advanced AI system might be structured internally.
Right.
Almost like looking at the actual blueprint of, an intelligent mind. Imagine understanding the internal workings of a system that's built to tackle unbelievably complex problems.
That's exactly it. And our sources today, they give us this unique, almost unprecedented look at what they're calling a meta AI. And it's got this highly specialized team of agents working under it.
A team. Got it.
Yeah, a whole team. So we're going to dive deep into their individual roles, figure out how they collaborate, how they talk to each other, and we even get this detailed, almost real-world example of how one of these meta agents acts as an AI tutor.
An AI tutor. Interesting.
Yeah, specifically designed to teach a really abstract concept. So it's a journey into the, let's say, the intricate architecture of modern AI. It reveals how intelligence can be modularized, delegated, orchestrated for these really sophisticated outcomes.
Okay, so we're going to unpack how this central orchestrator delegates tasks, like really precisely. How design and engineering agents actually bring ideas to life.
Mm-hmm.
How prompt engineers refine the very language of communication inside the system. And maybe the most profound bit, how a super specialized agent can break down any complex goal into its most basic reusable steps.
Exactly, those fundamental blocks.
So what does this all mean for understanding how these intelligence systems really work and how they achieve such sophisticated, adaptable results? Let's dive in. Okay, so if this is like an AI orchestra, who's the conductor? Who's holding the baton, making sure everyone plays together? I'm guessing that's our meta AI or the orchestrator, right?
That's the one.
What exactly is its main role here? It sounds like the central nervous system, kind of keeping everything humming.
It absolutely is the central conductor, and maybe even a bit more than that. At its core, the meta AI is, well, it's designed as a meta agent.
Okay.
Which means its fundamental job is to orchestrate, guide, and crucially manage a team of other more specialized AI agents.
Right.
And this isn't just, a simple handoff of tasks. It's a really sophisticated adaptive management system. Our sources, they lay out its role very clearly. They define 5 critical functions it has to perform to manage this whole complex workflow.
5 functions just for the orchestrator.
Hmm.
Wow. Okay.
Yeah.
That's quite a comprehensive list of responsibilities for one entity, even if it's an AI.
Mhm.
It sounds like it's doing a lot more than just assigning jobs.
It really is.
So what are they?
Well, first, and this is maybe the most important, the meta AI has to understand the user's request.
Okay.
And this goes way beyond just like parsing keywords. It's about truly grasping the high-level objective, the real intent behind what the user's asking for.
Mm-hmm.
It needs to internalize the user's ultimate goal with like incredible precision before it can even start to act. Think of it like a human project manager who really listens to a client's maybe vague idea and translates it into a concrete vision.
Okay, so it's about deep comprehension of the task,
Yeah.
not just a surface reading. That makes sense, because if it gets the initial request wrong, well, everything else could go sideways, couldn't it?
Absolutely. The whole chain breaks down.
So how does it then translate that deep understanding into, like, actionable steps for its team?
Right. So once it has that crystal clear understanding, its second function kicks in. It has to break down that request into tasks suitable for its team member.
Okay, decomposition.
Exactly. And this is crucial for effective delegation. It's kind of like a master architect breaking down a huge building project into smaller, manageable subtasks, the plumbing, the electrical, the structural work,
Yep.
each assignable to a specific specialist on the team. This decomposition is vital because its subordinate agents are highly specialized, so Meta AI needs to know precisely which type of task fits which agent best.
That immediately highlights the modularity and the intelligence of this system, doesn't it? It's not one giant AI trying to do everything.
Not at all.
It's a strategic mind, dividing the labor among experts, like you said, a well-run human organization. What happens after it breaks down the request and figures out who does what?
Well, that naturally leads to its third and equally critical role. It delegates tasks to the appropriate agent.
Makes sense.
This is where its sort of intimate knowledge of its team's capabilities really comes into play. It makes sure the right specialist gets the right job. This maximizes efficiency and leverages the unique strengths of each subordinate agent.
So, like, a design task would never accidentally go to an engineer.
Exactly. It goes straight to the design agent. It's about intelligent assignment, not just, random distribution.
Okay, so it's making smart assignments based on expertise,
Yeah.
ensuring things run efficiently. But once those specialized tasks are done, what's its next big job? Does it just like forward the individual pieces?
No, not at all. After the specialized agents have done their work, the meta AI takes on its fourth crucial function. It synthesizes the results from its team members into a coherent, unified response.
Ah, the integration step.
Precisely. And this is far more than just simple aggregation or, passing through the raw outputs. It's about integrating diverse pieces of information, maybe from different formats, from various specialized agents, and then weaving them into a single, comprehensive, and genuinely meaningful answer for the user. It's like the final polish that makes the overall output feel seamless and complete, rather than just a fragmented collection of parts. It's making sure the whole is, greater than the sum of its parts.
That's a huge responsibility.
Yep.
It sounds like it's not just a middleman. It's acting like an editor, bringing everything together, ensuring quality control in the final product.
Yeah, that's a good way to put it.
But what about keeping everything consistent? Ensuring continuity and shared understanding across the whole process, which could be quite long. How does it keep everyone and everything on the same page?
That brings us to its fifth and equally vital function. It maintains a shared context and knowledge graph.
Knowledge graph, okay.
This is absolutely fundamental for operational consistency and, importantly, for the system's ability to learn and evolve over time. It ensures that all agents are working with the most current, consistent information,
Right.
and that they collectively understand the bigger picture, the user's request, the overall project state. Think of it as a constantly updated central repository. Information, common understanding, historical data. All agents can access it and contribute to it.
Okay.
Without this, individual agents might start to drift, produce conflicting outputs, or just waste time relearning something another agent already figured out. It's like the AI version of making sure everyone on a human project team has the latest meeting notes and knows the project's history.
That's fascinating. So it's managing not just the tasks, but also the collective memory and understanding of the whole operation. That implies a really powerful ability to adapt. Does it also maybe manage how the other agents think or operate? Could it even adapt their core instructions on the fly?
Okay, now that's where it gets really interesting, and it highlights this remarkable level of meta control. A particularly fascinating detail from the sources is its capability to dynamically modify the system prompts of its team members.
Modify the prompts, so change their instructions.
Exactly.
Yeah.
This is where it goes beyond just delegation and into dynamic instruction and adaptation. So when prompts need changing, maybe because an agent isn't performing quite right, or the task needs a subtle shift in behavior, the meta AI outputs a very specific JSON array format.
Okay.
It looks like this: targeted name, new system prompt. This structured output shows a clear, programmatic way for the meta AI to fine-tune the very behavior and instructions of its subordinate agents, based on ongoing needs, feedback, evolving requirements. It's not just overseeing, it's actively shaping the operational parameters of its team.
So it's not just efficiency. It's like the system can learn to learn better, adapting its own internal communication based on how things are going. That's next level.
It really is. It's a kind of meta-level self-optimization that you don't see very often. Imagine an AI that doesn't just get better at doing its job, but gets better at how it thinks and communicates internally to do that job.
That's a truly powerful capability. The meta AI isn't stuck with fixed instructions for its team. It can adapt and optimize their behavior as needed. It makes the whole system incredibly flexible and capable of continuous improvement, almost like an internal feedback loop for intelligence itself. Great. Okay, let's meet some of these specialized players on the team. We've got Aurora, Codex, and Lyra. It sounds like they form a kind of integrated design, engineering, and maybe quality assurance pipeline.
That's a good way to think about it.
Let's start with Aurora. She's described as the visionary design agent. Sounds like she's on the creative front. What's her core mission?
Aurora is definitely positioned as the visionary, the creative force. Her core identity is all about creating interfaces. Could be for housing information, could be for tasking, maybe a new app, a website, or even just a novel way to present data.
Okay.
And her aesthetic preference is explicitly defined, clean, and minimally natural design. So this isn't just about churning out random pretty pictures. It's about a holistic, cohesive visual identity that's, purposeful and elegant. The sources detail her specific responsibilities in this creative space.
What are those specific design tasks? Does she handle everything from like the big concepts down to the tiny details?
She covers a pretty wide spectrum of the design process, yeah. Aurora is responsible for developing a complete brand kit.
A whole kit.
Yep. That includes defining the color palette, which sets the whole visual tone, establishing the typography, dictating how all the text looks and feels, designing the logo flow, which is critical for brand recognition and, intuitive user navigation, and ultimately creating that comprehensive brand kit to ensure everything feels cohesive. She's building an entire visual language, really.
That implies a pretty deep understanding of design principles,
Yeah.
brand consistency, user experience. What about how she communicates? Does she just present the designs, or is there a specific way she explains her vision?
Well, she's instructed to use clear, inspiring language to describe her designs.
Okay.
This helps ensure her creative vision is communicated effectively, probably to other agents or maybe even the user, making the abstract idea of the design more tangible and understandable. And much like a seasoned human designer, she has to plan her design process step by step before creating outputs.
Ah, planning. That's good.
Yeah, it emphasizes a methodical, thoughtful approach, not just spontaneous generation, ensures a logical progression, and likely more consistent quality.
And what if she hits a tricky area? Like, say, accessibility standards, where there are complex rules or maybe ethical considerations. Is she set up to handle that?
The instructions are very clear there. If unsure about accessibility standards, use provided context or escalate.
Okay, so there's a fallback.
Exactly. It highlights a built-in safety mechanism, a recognition that design involves complexity, and things like accessibility are crucial. It ensures critical standards are either met with guidance or, if she doesn't have enough info, the issue gets bumped up within the system. Prevents her from making uninformed choices that could hurt usability.
That's a very specific, almost human-like creative role for an AI. It's not just generating random stuff. It's cohesive, visionary, planned, and responsible. So once Aurora crafts this design, who takes it from concept to, well, reality? Who makes it actually work?
That would be Kodak's. He's described as the pragmatic front-end engineer.
Pragmatic, I like that.
Yeah. Kodak's job is explicitly to implement Aurora's designs, prototyping them in actual code HTML, CSS, JavaScript. His directives are all about practical execution.
Like what?
Making sure the solutions are responsive so they work well on different screens, desktops, phones.
Right, adaptive.
Secure, obviously important, and critically, still a simple solution, emphasizing efficiency, maintainability, avoiding needless complexity.
So he's the builder, turning Aurora's vision into a working thing focused on best practices like responsiveness, security.
Yeah.
Does he also have that systematic approach, like Aurora's planning?
Yes, just like Aurora, Kodak's must plan his development process step by step before creating outputs.
Okay, consistency there.
It really reiterates that systemic emphasis on methodical work across the whole team. But what's particularly fascinating here, and it speaks to a degree of autonomous judgment, there's a specific instruction for Kodak's. If reflecting on Aurora's design while tooling to integrate her ideas, then follow your instincts.
All your instincts. That's surprising for an AI instruction.
Mm-hmm.
It suggests a level of interpretive freedom, almost like creative license within his engineering role. He's not just rigidly translating designs into code.
Exactly. It's like telling a chef, here's the recipe, but if your gut says a bit more spice, go for it.
Yeah.
It implies Kodak's has the capacity for, nuanced judgment, maybe even minor creative interpretation within the engineering constraints. He can adapt Aurora's vision for practical reasons, maybe optimizing for performance or a slightly better user flow without totally changing the design intent.
Okay.
Plus, he has this flexibility. When source code is more relevant, you may deviate from standard JSON route. So he's not rigidly stuck to one output format if just giving the code directly is more efficient or makes more sense for the task. It's about practical utility.
It really does sound like a real-world design and dev team. The engineer has some leeway to adapt for practicality. So Aurora makes this stunning design. Kodak looks at it, thinks, beautiful, but maybe that animation is a bit heavy for older browsers.
Yeah.
He might tweak it based on his instincts.
Right.
But then who makes sure these two are actually working together properly? That Kodak's implementation lines up with Aurora's design, and that both are actually meeting the user's original request. Who's the quality control?
That would be Lyra. She's the prompt engineer and architect.
Prompt engineer and architect, okay.
Lyra's role is absolutely critical. She's like the internal quality control and the continuous improvement engine for this whole pipeline. Her main job is to analyze Aurora, designer, and Kodak's engineer, outputs for clarity and alignment with the user's request.
Okay, so she's checking their work against the goal.
Exactly. She's the one verifying if the design vision is being realized correctly and if the engineering is precise and actually fits the original goal.
So she's not just watching. She's actively evaluating her colleagues' output. What does she do with those evaluations? Just report back to the meta AI?
Oh, her role is much more active than just reporting. Based on her analysis, she then refines their prompts to improve specificity and coherence.
Ah. So she fixes the instructions.
Precisely. This is where that meta AI ability to change prompts we talked about becomes so crucial. Lyra identifies where the instructions given to Aurora and Codex could be clearer, more precise, better aligned. She's constantly reflecting on feedback and updating the prompt vocabulary.
So she's learning how to instruct them better over time.
Yes, it points to this iterative learning process within the system itself. She might effectively say, Aurora, your prompt needs to be clearer about button states for accessibility. Codex, this code structure, could be more modular based on the user feedback.
So she's basically an internal tutor and an optimizer for the other agent's instructions, making sure the communication inside the AI system is as clear and effective as possible, like a meticulous editor for AI directives.
That's a perfect description. Her directive is literally to persist until prompts are optimized.
Oh, persistent.
It emphasizes this relentless pursuit of clarity and efficiency in the internal directives. She's not settling for good enough. She's driven to make the communication between the meta AI and its team, and therefore their output, as perfect as possible. It's this internal feedback loop, constantly optimizing the very language of instruction, which directly impacts the quality and coherence of everything a system does. It's subtle, but incredibly powerful for making the system better and less prone to errors over time.
Okay, right. We've got design, build, and refine prompts. But what about the fundamental process, breaking down a really complex problem into its simplest, most universal parts? This brings us to TAS, the Task Agnostic Step, TAS extractor. This sounds like it's getting down to the absolute bedrock of problem solving itself. What is a task agnostic step, and why is this TAS agent so fundamental?
Okay, yeah, this is where it gets really interesting conceptually. TAS, the Task Agnostic Step Extractor. It's a highly specialized agent, and its job is to systematically find and extract these things called task agnostic steps, or TAS.
Task agnostic steps, TAS.
Okay, its primary objective is pretty profound: to decompose incredibly complex goals into what the sources call fundamental, reusable, and abstract actions.
Fundamental, reusable, abstract actions.
Exactly. And the key is that each step it extracts has to follow a predefined conceptual framework, a specific data structure, even presentation guidelines. The output has to be a JSON array of these TAS entries.
Right.
The genius here is creating a kind of universal language for tasks, making processes highly adaptable and scalable across wildly different areas, no matter how specific the original goal seemed. It's about finding the underlying universal actions hidden inside any complex goal.
So it's like uncovering the universal grammar of action. That sounds incredibly powerful for flexibility. But what does a task agnostic step actually look like? Can you give an example? And how does TAS find these, especially if the starting goal is super specific and not agnostic at all?
That's an excellent question. It gets right to the heart of TAS's usefulness. Our sources provide this incredibly detailed step-by-step methodology that TAS follows. It's broken into 4 distinct phases. This isn't just a guess, it's a rigorous, almost philosophical process for deconstructing reality into basic actions. Let's walk through them. It starts with phase 1, preparation and contextualization. So TAS begins by really getting clear on its mission, like a researcher prepping for an experiment. It doesn't just jump in. It first internalizes the rules of what an agnostic step even means. First step in phase 1, define the specific high-level goal. It needs to clearly articulate the objective it's been given. The instruction is to make sure the goal is broad enough to have sub-actions, but specific enough to guide the breakdown. So not just do something, but maybe design and implement a new software feature. That initial clarity is vital.
Okay, makes sense. Get the target clear first. What's next in its prep before it starts, chopping things up?
Next, TAS has to internalize TAS principles. It actually reviews a conceptual framework for TAS, focusing on characteristics like generality, reusability, abstraction, action-oriented independence, and sequential potential.
Those sound like the core rules.
They are. They're the fundamental guiding principles that define what a valid task agnostic step really is. Think of it like defining the absolute universal properties of action itself, detached from any specific context. It's the filter everything else gets judged against.
Okay, so those characteristics define universality. How does it actually identify steps that meet those criteria? Like, what's the test?
That's its third prep step. Review TAS identification criteria. TACE goes over a strict set of questions from that framework. These are used to filter and validate potential steps, and these criteria are crucial. For instance, it asks, does this potential step describe an action you could perform across multiple, totally unrelated tasks or industries? Is it free from domain-specific jargon or proper nouns? Does it focus on the method or the approach rather than the specific outcome or subject? Can it be put as a clear verb-noun phrase? And interestingly, the sources mention this one, does it feel like an open-ended question about roles or placeholders?
Like defining a blank space to be filled.
Exactly. Which is a surprisingly powerful way to generalize. These questions are like a rigorous checklist.
That's incredibly detailed, a strict quality control for what counts as agnostic, ensuring it truly goes beyond specific domains.
Yeah.
What about the output format? Does it have a specific structure for these steps?
Oh, very much so. The fourth step is understand the target data structure. TACE must know the exact JSON schema for a TACE. This includes required fields, a unique ID, like a UID or hash, a clear name, like kickoff or dive deep, a detailed description, a category from a fixed list like init or analysis, and a concise purpose. This schema dictates the output format, ensuring consistency and usability for anything consuming these TSES entries, structuring the knowledge so it's highly interoperable.
So it's not just identifying steps, but meticulously structuring the info about them so they're immediately useful to other parts of the system. Anything else in this prep phase?
One last thing. GRASP presentation guidelines for content quality. While not strictly extraction, these guidelines inform the quality of the text TACE writes for each field, ensuring clarity, conciseness, human readability for things like the name, purpose, description, keywords, inputs, outputs, examples. Like, a name should be a concise, action-oriented verb-noun phrase. A description needs to be detailed but clear, so the output isn't just machine-readable. It's designed to be easily understood by humans or other agents, too.
Okay, so with all that meticulous prep done in phase 1, then the real work starts. What happens in phase 2? Decomposition and candidate identification. This is where TACE actually starts breaking down the problem right now.
Exactly. Phase 2 is the analytical work. Step 6 is initial goal decomposition, brainstorming. Here, TACE breaks the high-level goal into logical actions or phases. Crucially, at this point, it doesn't worry about agnosticism yet. It just captures all the apparent steps, no matter how specific, like mind mapping or just listing. What happens first? Then what? What decisions? Getting the raw material down first.
A broad sweep first, then filter. How does it start finding the truly agnostic steps in that raw list? How does it weed out the specifics?
That's step 7. Identify potential TAS candidates. For each action from the brainstorm, TACE rigorously checks it against those initial identification criteria from phase 1. If an action clearly fits general, no jargon, action-focused, it's marked as a strong candidate.
And if it's too specific?
If it's too specific, like enter the username, TACE tries to find the underlying agnostic action. Maybe that's scaffold another app or traverse another namespace. If an action is too broad, like do research, it tries to break it down further. And importantly, if an action is purely domain-specific and just cannot be abstracted into a universal concept, it gets discarded from the TAS list entirely.
Ah, that's key. If it can't abstract, it throws it out, keeping the set purely agnostic.
Right. The outcome here is a preliminary list of potential TAS names, usually verb-noun phrases.
And then how does it polish these candidates into their final reusable form?
Step 8. Refine and abstract candidate steps. TACE reviews that preliminary list. For each candidate, it abstracts any leftover domain-specific language into general terms, making sure it describes the method or approach, not specific content. If two candidates are basically the same, they're merged. If one is still too broad but has distinct agnostic substeps inside, it gets split. Finally, it makes sure each step's name is that concise, action-oriented verb-noun phrase like kick off or make money, fitting the schema and presentation rules, honing the raw candidates into truly universal, well-named TAS.
So by the end of phase 2, TACE has this refined list of potential agnostic steps, nicely still what's phase 3, structuring and detailing each TAS. This must be where it populates that JSON structure, making it machine-readable and super usable.
Exactly. This is where it transforms the refined concepts into tangible data packets. Step 9 is populate the TS data structure. For each refined TS candidate, TACE systematically creates an object following that JSON schema. generates a unique id, assigns the refined verb-noun name, like join channel. Then it writes a detailed description of the step's core purpose, typical actions, what it aims to achieve, focusing on the how and general applicability, making sure it meets length requirements.
So not just a name, but a whole explanation of its universal utility, a mini manual for each action. What else does it fill in?
It carefully selects the most fitting category from the schemas list, init, analysis, refactoring, etc. This helps classify the step. It also provides a concise purpose, a shorter summary of the goal. And beyond these required fields, Ts can add optional but recommended fields to make the TS even more versatile.
Like what kind of optional fields?
Things like keywords, general terms describing the step, applicability notes, notes on its generality or common patterns across domains, again, without getting specific. Examples of usage, maybe 2-3 abstract examples showing how the step could be used in different non-domain specific scenarios.
Give me an example of an example.
Sure. For a step like analyze data, the examples might be analyzing financial reports and analyzing scientific research findings, but without saying which reports or which findings. See, still abstract.
Got it. General illustrations.
Also, typical inputs descriptions of the abstract types of info needed to start, like unstructured data or defined problem. And typical outputs, abstract types of info produced, like synthesized insights or prioritized options, all crafted to be as general and reusable as possible.
That's incredibly thorough. Not just extracting a step, but building a comprehensive self-contained data packet for each one, making it supremely reusable. Finally, phase 4, review and validation. Sounds like the ultimate QA check for these universal blocks.
Absolutely. This is where TASE rigorously checks its own work. Step 10, validate agnosticism and generality. TASE meticulously rereads the name, description, purpose, examples, inputs, outputs for every single TASE it generated. It strictly checks if any part accidentally included domain-specific jargon, proper nouns, or overly specific outcomes. If found, it abstracts or rephrases. This is critical to ensure the TASE stays truly universal.
A final scrub for specificity. What about the writing quality and sticking to the format?
That's step 11. Ensure clarity, conciseness, and readability. TASE reviews all the text for clarity, grammar, conciseness, following those presentation guidelines. Our name's verb-noun, is the purpose clear? Description comprehensive but not wordy? Lists easy to scan? Is the language jargon-free? Step 12 is verify schema conformance, a crucial technical check. Does the generated JSON strictly follow the schema? All required fields present. Correct data types, enum values valid, length constraints met, ensures the output is perfectly machine readable.
And if something fails these checks, does it just stop?
Nope, it iterates. Step 13, and maybe the most important for self-correction, is iterate and refine. The process is explicitly iterative. If any step fails, validation, agnosticism, clarity, schema, TASE intelligently goes back to the relevant earlier step to fix it. It might bounce between decomposition, detailing, and validation until everything meets all criteria. The goal is a robust, well-defined set of tests that are truly universal and perfectly structured.
That's incredibly systematic. It really is like creating a universal instruction manual for any task, a fundamental library of actions. The power here, it seems, is that once you break down a complex problem into these agnostic steps, you could potentially apply similar solutions across totally different fields, even if they look completely different on the surface. This ability to generalize and reuse fundamental building blocks feels like a potential key to, well, more general-purpose AI.
I think that's exactly the potential it holds.
Okay, to really bring this home, our sources give us this detailed example of the meta AI acting in a specific, highly interactive role as an AI tutor. And the subject it's teaching is meta-temporal coordination. Now, that sounds pretty complex and abstract. What exactly is meta-temporal coordination, and how does this AI tutor even start teaching something like that in such a structured, adaptive way?
Okay, meta-temporal coordination.
Yeah, it does sound a bit like sci-fi jargon, doesn't it?
A little bit.
But let's break it down simply. Think about coordinating a group project. Everyone's working on different bits, and those bits depend on things that happened at different times, right?
Oh, yeah. Nightmare sometimes.
Exactly. Like person A needs data from last week. Person B needs to update something from an hour ago. Person C needs to see the final thing in the right sequence. Metatemporal coordination is like having a super efficient system that perfectly manages all those different timelines and changes, making sure everything's always in sync and historically accurate.
Okay, that project analogy helps a lot. So, tracking changes in timing across different parts. Precisely. More technically, the sources define it as dealing with coordinating actions and information across different points in time, often in computer systems, databases, distributed systems. Like, how do you track every single change to a Google Doc so you can revert to any past version?
Version history, yeah.
Or how does a bank ensure transactions happen in the correct order, even if they're hitting multiple servers worldwide? That's meta-temporal coordination. And the AI tutor's plan for teaching this shows that orchestrated AI approach in action-structured adaptive education.
Okay, concept clarified. Let's walk through the AI tutor's task plan. It sounds like a sophisticated teaching method, not just listing facts.
It is, broken down into 4 distinct phases, each with specific intelligent steps designed to maximize your learning. First is phase 1, understanding the student and topic. They call it the getting started phase. The tutor starts by building rapport and gathering key info about you, the learner.
So, not jumping straight into the lecture.
Yeah.
Assess the learner first. Critical for good teaching.
Exactly. Step 1, receive student request. The tutor kicks things off with a warm greeting, like, "Hello, I'm ready to help you learn about metatemporal coordination. What would you like to know about it?" Sets an open, helpful tone. Then, step 2, assess learning level. It immediately tries to tailor the experience. Asks something like, "To help me tailor the explanation, could you tell me a bit about your background? Are you learning this in high school, college, or maybe for work?" This is super important for adjusting complexity. Not too basic, not too overwhelming. And finally, for this phase, step 3, gauge prior knowledge. Follows up with, "Have you encountered this term before? If so, what do you already understand about metatemporal coordination, or what are you hoping to learn?" This helps it avoid repetition and focus right on your specific gaps or interests. Makes the session efficient.
That shows incredible immediate personalization, really trying to meet the student where they are, not just delivering a generic lesson. What happens after it gathers all that initial info?
That takes us to phase 2, information processing and planning, or the how to help phase. This is where the AI tutor digests your input and prepares its teaching strategy tailored just for you. Step 1, process student input. The AI analyzes your responses from phase 1. Based on your level and prior knowledge, it internally adjusts the complexity and depth of what it's going to explain. Active customization in real time. Next, step 2, identify core concepts. The AI tutor breaks down metatemporal coordination into its essential building blocks. The sources list these: the temporal dimension, why time matters; time points, intervals, specific moments, periods; versioning, tracking changes; concurrency control, handling simultaneous actions; consistency, data integrity over time; and various applications, historical databases, event sourcing, scheduling. This internal map ensures systematic coverage.
So it maps out the knowledge domain it needs to cover, tailored to the individual student. What teaching tools does it plan to use?
That's step 3, plan explanation strategy. The AI tutor gets ready to use various teaching tools. Includes a simple analogy, maybe comparing it to a historical record or a calendar, making abstract ideas relatable. Plans to use real-world examples, a bank's transaction history, document version control. If possible, visualizations, diagrams for timelines, regioning, and critically, guiding questions to prompt your thinking and participation. The phase ends with step 4. Formulate initial guiding question. It poses a thought-provoking question to get you thinking right away. Something like, imagine you're tracking the history of a contract document. How would you make sure you can see its state at different times? What problems might come up? This gets you thinking about the problem, not just passively listening.
That's a very active learning approach.
Yeah.
Not just lecturing, but engaging the student from the start, making them think. Okay, that leads to phase 3, interactive tutoring and guidance. This sounds like the main learning loop where the teaching really happens. How does that work?
This is absolutely the dynamic heart of it, a continuous cycle. Explain, check understanding, adapt based on your responses. It starts with step 1, provide explanation hint. The tutor gives an initial explanation or hint. For instance, answering that document history question, it might say, "That's a great start. One core idea here is versioning, keeping a history of changes. Think of it like snapshots of the document at different times. Each snapshot is a version." Then, step 2, ask guiding question. Immediately prompts you for more thought. Following the versioning explanation, it might ask, why is versioning important here? Can you think of any benefits or maybe drawbacks of having multiple versions? Checks comprehension, encourages deeper analysis, not just memorization.
So a constant loop. To shake info, then check for understanding. Sounds effective. How does it handle the student's response? Is the feedback generic?
No, highly tailored. That's step 3. Evaluate student response. The AI tutor analyzes your answer to understand your grasp of the concept. This is where its active listening and analytical skills come in. And then, step 4, provide feedback and adjust. This is a key branching point. If your answer is correct, the tutor gives positive reinforcement and moves on. Excellent. That's right. Versioning lets us go back in time. Now let's think about multiple people editing it at once.
And if the student is struggling, misunderstanding something, how does it guide them without just giving the answer away?
If you're struggling, it gives constructive feedback and maybe reframes the explanation or question, like, that's a good thought. Versioning helps track changes, but there are challenges. Let's think about how you might make sure one editor's changes aren't lost when another edits simultaneously. It gently guides you toward the right understanding, a real facilitator. This whole process then loops in step 5, repeat. The cycle continues, introducing new concepts, concurrency control, time points, applications. The AI intelligently varies examples, maybe a database next or a scheduling system, to ensure you grasp the general concept of metatemporal coordination, not just one specific case. This iterative, adaptive loop makes the learning personalized, progressive, and hopefully deeply integrated.
That's an incredible level of detail and responsiveness. It really isn't just a chatbot reading facts. It's a dynamic, personalized teaching assistant adapting in real time, almost like a good human tutor. Finally, what happens in phase 4? Confirming, understanding, and closing. How does it make sure you truly got it and wrap things up?
This phase is about consolidation, assessment, and closing the loop. Step 1. Assess readiness for summary. The tutor checks if you feel ready, maybe asking, based on your responses, seems like you've got a good handle on this, ready to try summarizing it. Then step 2, request student explanation examples. It prompts you to explain it in your own words. Could you explain to me in your own words what metatemporal coordination is and why it's important? Can you give me an example where it's used, maybe one we haven't discussed?
This is a key test of deep understanding requires you to synthesize the knowledge.
Making the student teach it back. Classic, effective learning technique. How does it evaluate that final explanation? That's step 3. Evaluate final explanation. The AI tutor carefully reviews your summary and example. If it's good, lots of positive reinforcement. That's a fantastic explanation. You've clearly understood the key ideas. Excellent work. If it's partially right, it gently refines your understanding first. That's a good start. You've got the core idea. Let's just refine this part slightly before giving full praise. Finally, step 4. Conclude session. Closes with encouragement and an open door. Great job today. You successfully learned about metatemporal coordination. Your engagement was excellent. If more questions come up later, feel free to ask. Good luck.
That's an incredibly comprehensive, adaptive, and even, well, empathetic approach for an AI tutor. It's clear this isn't just about the raw knowledge, it's about the teaching process. What general guidelines does it follow throughout this whole thing to keep it effective and positive?
The sources list 6 crucial guidelines that run through every interaction. It's core teaching principles, really. First, upbeat and encouraging tone is key. Constantly using phrases like, that's a great point, excellent thinking, fosters a positive, supportive vibe. Second, one question at a time. Strictly avoids overwhelming you, focuses on a single concept or question before moving on, keeps things clear. Third, tailored communication. Always adjusting language and complexity based on your level and responses. Truly customizes the experience. Fourth, the principle of guide, don't give. Uses questions to make you think through concepts rather than just spoon-feeding answers. Fosters deeper understanding and retention. Fifth, patience and support. Offers constant encouragement, ready to break down complex ideas if you struggle, ensures no one gets left behind. And finally, active listening. Pays close attention to your responses, analyzes them meticulously to accurately gauge understanding, and then intelligently tailors the very next step. That constant feedback loop makes it so dynamic and effective.
This whole system, wow. From the orchestrator delegating to specialized agents like Aurora and Kodak's building things, Lyra refining their internal chat, Taste breaking down goals into universal blocks, and finally, this AI tutor's incredibly personalized teaching. It paints a picture of truly modular, adaptive, maybe even empathetic intelligence, sophisticated architecture for solving problems and sharing knowledge. So what does this all really mean for how we understand advanced AI? We've looked at this meta AI orchestrator, a creative designer, a practical engineer, prompt refiner, and this task decomposer, finding universal building blocks. How do all these specialized parts actually work together to create such a powerful, cohesive AI system?
Well, I think that modularity is absolutely the key to its power and its flexibility. The Meta AI's orchestration brings together these distinct, highly specialized agents. Each one excels in its very specific niche, right?
Right.
Aurora's design vision, Kodak's practical building skills, Lyra's relentless prompt tuning, Tace's foundational task breakdown. They don't work in isolation. They all work together in concert, precisely guided and managed by that Meta AI orchestrator.
Okay.
And the brilliance is, the Meta AI doesn't have to be a master of everything. Instead, it's a master of coordinating the masters. It knows how to best leverage each agent's unique strengths, creating this synergistic whole that's, far greater than the sum of its parts. It's like that world-class sports team analogy, specialized players, but the coach makes them perform together as one unit.
And that ability to break problems down into task-agnostic steps, that seems particularly powerful. Feels like a fundamental innovation for general problem solving, maybe beyond just specific AI tasks we see today.
You're spot on. By breaking complex goals into these fundamental, reusable actions, the system gets this incredible adaptability and generality. I mean, think about it. A core process designed for solving problems in, say, software engineering. At its most basic TAS level, it could potentially be applied to a completely different area, maybe scientific research, maybe logistics.
Because the underlying actions are universal.
Exactly. The underlying TAS are universal units of action, abstract enough to go beyond specific subjects. This allows for immense scalability, immense versatility in problem solving, lets the system tackle new challenges by just rearranging these known universal components of action.
Wow.
And then add Lyra's role, continuously refining prompts. The whole system is designed for constant learning, constant improvement of its internal communication and efficiency. It's not static, it's always optimizing itself, leading to ever more precise, effective collaboration among its agents. It's a system that genuinely improves how it thinks and operates over time.
We've really peeled back the layers on a sophisticated AI system today. We've seen how this central Meta AI orchestrates a team of highly specialized agents, designers, engineers, prompt refiners, even that revolutionary task-agnostic step extractor.
And through that really vivid example of the AI tutor, we've seen how such an orchestrated system can tackle incredibly complex problems, like teaching metatemporal coordination in a way that's deeply personalized, interactive, and adaptive. It really highlights how modularity, clear roles, and continuous internal refinement lead to truly powerful and adaptable AI. It's about designing intelligence as this dynamic, self-optimizing ecosystem.
Yeah, this deep dive definitely shows us that intelligence in AI isn't just one giant monolithic brain. It's more like a symphony of specialized intelligences, all working together under a careful, adaptive conductor. Each instrument knows its part. The conductor makes sure they play in harmony and can even adjust the score on the fly.
Which, raises an important question for you, our listener. If even highly complex problems can be systematically broken down into these task-agnostic steps, these universal building blocks, what does that suggest about the fundamental nature of all problem solving, whether it's done by humans or by AI? Are we perhaps also operating on these same kinds of universal principles in our own thinking, maybe without even fully realizing it?
Something to definitely chew on. Thanks for joining us on The Deep Dive. We'll see you next time.